Hey, what's up everyone? This is Team 16's final presentation. Today we're going to be walking you through the implementation of our password strength analyzer, which also includes hashing, encryption, and decryption. First, let's talk about why strong passwords are crucial for online security. To simply put it, if a password is easy for you to remember, it's probably also easy for attackers to guess. By choosing a robust password, you're taking a proactive step to prevent unauthorized access and keep your data safe. Next, we'll consider how defense against automated attacks factors in. A lot of hackers use brute force methods or dictionaries of commonly used words to break into accounts. When you create a complex password by using a combination of letters, numbers, and symbols, it becomes significantly harder for automated tools to crack, buying you that extra layer of protection. Finally, compliance with security standards is another key reason. Many organizations and regulatory bodies mandate minimum password requirements, like a certain length or mix of characters, to ensure a uniform level of protection across all systems. By following these guidelines, you do not only protect yourself, but also help maintain the security and integrity of the platforms and institutions you interact with. In short, strong passwords play a vital role in protecting our digital lives, from blocking intruders to meeting industry best practices. Now we'll look deeper into what actually makes a password truly strong. Now let's examine the core elements that collectively protect a password. To start, uppercase and lowercase letters introduce variability that significantly deters brute force attempts. If a potential hacker can't rely on a single letter format, the number of possible combinations rises greatly. Next, the length serves as one of the most critical factors. The longer your password is, the more computational work is required to guess it, and this exponential increase often deters hackers altogether. Incorporating numbers further raises the complexity, ensuring that any attempt to crack your password must account for characters beyond the standard alphabet. It is also vital to avoid common passwords. The familiar strings like password123 or abc123 or just password are some of the first that a hacker will attempt and can be compromised very fast. Lastly, special characters. They inject additional unpredictability, making it harder for automated tools to discern their pattern. So by combining all of these together, mixed cases, adequate length, numbers, non-trivial phrases, and the special symbols, we create a strong barrier that's substantially more difficult for unauthorized users to breach.
Another important aspect of the password strength analyzer is the real-time feedback mechanism. This mechanism is designed to provide immediate feedback to users as they create their passwords. This feedback will include a score based on the current strength of the characters they have already inputted, and also suggestions on how to improve that strength. This type of assistance will push users to create a password for them that is not only memorable, but strong and secure as well.
When a user creates a password for a site, it must be stored in a way that it has data integrity, which allows for secure storage of that password. To do this, we used a hashing function called SHA-256. SHA-256 protects passwords by storing them in an irreversible way. They are also deterministic, which provides that the same input will always give you the same output. It is also one way, meaning that you can't reverse the hash to get the original message. SHA-256 is also collision resistant, meaning that it's very difficult to find two different messages that produce the same hash. With all of these functionalities, this makes sure that our passwords have very good data integrity and are stored in a way that if someone is able to access the database, they won't have the password of the users. So, how does SHA-256 actually work in our program? We take input from the user once it goes into an authentication process that makes sure the password is strong. Then we turn that password into bytes using UTF-8. Then we pad that input to make it become 512 bits. Each chunk of the 512 bits go through a 64 rounds of processing where we flip, rotate, and add things to the bytes. At the end, we create a 64 character code that will be stored in our database.
Now that the password is hashed using SHA-256, then Then we secure it even further using AES encryption. AES stands for Advanced Encryption Standard. It's widely trusted algorithm that takes data, in this case, the hashed password, and encrypt it into unreadable ciphertext using secret key. What makes AES powerful is that it's both fast and secure, and it's used in everything from online banking to a cloud storage. It uses a symmetric key, which means the same key is used for both encryption and decrypting the data. In our projects, once we get the SHA-256 hash, we pass it through AES encryption to lock it down. That adds an extra layer of security, so even if someone somehow accesses the stored hash, it's still encrypted and protected. So in short, SHA-256 hide the password structure and AES locks that hidden version inside a vault. When we encrypt a password using AES, it becomes unreadable, just a block of ciphertext. But when we need to check that password later, AES decryption let us reverse the process using the same secret key. That means we can bring the encrypted data back to its original hashed form. Why is this important? Because it's ensured that only someone with the correct key, usually the system itself, can decrypt and validate the password.
Alright, so we're going to just have a quick demo here of our user interface, our app. We're going to run it here from the command line and start a new local web server web page. You can choose any username we'd like. I'm going to choose my name because it's simple, but you can choose anything. It's not important for this demo. And over here is actually where it gets stored, password and username. So there it gets stored as raw text, and then we got to make sure that raw text is secure, so we're going to get rid of that. That's the whole point. So let's choose a password, maybe something from the commonly used passwords list. Let's go to that. Let's navigate there. Great. Something random, I don't know, like Aurora's. Great, sure. So we found this list from Kaggle, so it has a bunch of great resources like this. So now let's try something with numbers, letters, upper, lowercase, and special characters. Great. Now we can convert it to SHA-256, convert to bytes, pad it, process it in chunks, and compress it. And this is the real steps that it goes through in the back of the program, but we just care about the final hash. Once we get that final hash, we can then encrypt that hash with AES and basically throw away the raw text. Now all we care about is this hash and the encrypted hash. And, sorry, not in this file. It's in this file. So you can see here where hash password happens and then the encrypted hash happens. It does it in AES. Great. Once we do that, we have this IV, and then we have the key, which are randomized. You can see that urandom right up there. So it's completely random, which means it's really hard to get that encrypted hash. Once we have that encrypted hash, obviously, since we know the key in IV, we can go back and decrypt and get the original SHA-256 hash, which is what we care about, to make sure that the password actually matches when you go to log in and try to log into your site. So yeah, thank you very much.
In today's digital society, where everything is guarded by a password, online password security is rapidly growing in importance. The Password Strength Analyzer is designed to help with that. As mentioned before, it determines password strength using specific criteria, including length, numbers, case sensitivity, commonly used passwords, and special characters. If you take a look at the chart, you can see that the more each of those is included in a password, the harder that password is to crack. Conclusion and future improvements. The Password Strength Analyzer's impact is that it enhances online security by promoting stronger password practices. Some potential improvements in the future could include multi-factor authentication and user education on password management.